Welcome to The Explainer. Today, we're diving into a really fundamental question in software design. How should your microservices talk to each other? If you get this right, you can build a system that's scalable and resilient. But if you get it wrong, well, you could be staring down performance bottlenecks and some seriously brittle code.
So here's our game plan for today. We're going to start with the big picture choice that really frames everything else. Then we'll get into the two main styles of communication, that's synchronous and asynchronous. After that, we'll see how they stack up against each other, and we'll finish up with a super practical guide to help you pick the right tool for the job.
All right, part one, the communication crossroads. The second you decide to break up a big application into these smaller microservices, you are immediately hit with a huge decision. How are these independent services actually going to coordinate with each other? And this gets right to the heart of it. What is more important for your project right at this moment? Is it all about developer productivity? Moving fast, having a system that's easy for new folks to jump into? Or is it about raw performance, squeezing every last bit of speed and efficiency out of your infrastructure? This one choice, the single question, is going to set the direction for pretty much everything else. That big choice between productivity and performance, well, it often maps directly to two communication patterns. Over on the left, we have synchronous communication. The best way to think about this is like a phone call. You make a request, and you literally have to wait on the line for an immediate answer. Then on the right, you've got asynchronous communication. This is way more like sending a text message. You fire off your message, and you can just move on to other things, feeling confident you'll get a notification when a reply comes in. So part two, the synchronous protocols. Let's really dig into that phone call model. These are the protocols you're going to reach for when one of your services absolutely needs an answer from another one right away to keep doing its job. And look, you just can't talk about synchronous communication without starting with the biggest player in the game, especially for web APIs, REST. The real magic of REST is that it's built from the ground up for developer productivity. It uses the standard language of the web, HTTP, and a data format, JSON, that's incredibly easy for people to read and for computers to understand. That simplicity makes it a total breeze to debug, and it's exactly why it's the default choice for any public-facing API. If you want other developers to integrate with your system easily, REST is the gold standard, period. But what about communication inside your own system? Where you control both ends of the conversation and nobody really cares if the data is human readable. When raw performance is the name of the game, that is the perfect use case for gRPC. This slide really highlights the trade-off perfectly. Instead of that easy-to-read text like JSON, gRPC uses something called protocol buffers. It's a super optimized binary format. It also demands the modern HTTP/2 protocol to make connections more efficient. What's the end result? Well, the messages are way smaller and way faster to process, making gRPC the absolute best choice for high-speed internal chatter between your own microservices. Okay, our next synchronous protocol is GraphQL. And this one was created to solve a really common headache for front-end developers: how to get data from the back-end efficiently. The superpower of GraphQL is that it lets the client call the shots. Just imagine a mobile app that needs to show a user's profile, their latest posts, and their followers. With a classic REST API, that might take 3 separate requests. But with GraphQL, the app can send one single, precise query asking for exactly that data and get it all back in one neat response. This kind of efficiency is a massive, massive win for front-end and mobile teams. Part 3, the asynchronous protocols. Okay, time to switch gears. Let's explore that text message model. We are now entering the asynchronous world, and this is all about building systems that are resilient, where services don't have to sit around waiting on each other. We'll kick things off with AMQP, the Advanced Message Queuing Protocol. This is the one you reach for when message delivery has to be guaranteed. No ifs, ands, or buts. A perfect example of this is an e-commerce checkout. When a customer places an order, you have to do a bunch of things, right? Charge their card, update the inventory, tell the shipping department. These are all separate services. With a system like RabbitMQ using AMQP, you just send an order-placed message. Now, even if the shipping service is down for maintenance, that message will just wait safely in a queue. When the service comes back online, it'll process the message. That guarantee of delivery is what makes AMQ so rock solid for critical business workflows. Next up, let's talk about Kafka. Now, while it's often grouped with message queues, it's really a different beast entirely. At its core, Kafka isn't a queue, It's a distributed, unchangeable log of events. So why is this log idea so important? Because unlike a traditional queue, where messages are deleted once they're read, events in Kafka's log persist. They stick around. And that is a total game changer. It means you can have multiple, totally independent services all reading from the same stream of events. A fraud detection service, a customer notification service, and a data analytics pipeline can all consume the exact same order-placed events at their own speed. You can even add new services a year from now that replay the entire history. This makes Kafka unbelievably powerful for real-time data processing. Our final asynchronous protocol is MQTT, which was specifically designed for the super challenging world of the Internet of Things. So think tiny sensors, smart home gadgets, and industrial equipment. The defining feature of MQTT is how incredibly light it is. I mean, when you have potentially millions of devices, and a lot of them are running on batteries with spotty Wi-Fi, you just can't afford the overhead of standard web protocols. MQTT is designed with a tiny message header and a simple publish-subscribe model, which minimizes both battery use and network bandwidth. It's this efficiency at scale that makes it the absolute go-to protocol for IoT. Part 4, the protocol showdown. Okay, we've met all the individual players. Now let's put them all on one chart, compare them side by side, and see where each one really shines. This table lays out the whole landscape so clearly. You can really see that split between the synchronous request-response protocols like REST and gRPC and the asynchronous event-driven ones like AMQP and Kafka. And notice the trade-offs, right? The synchronous protocols often use familiar HTTP, while the async ones rely on lower-level TCP for better performance and reliability. It just becomes crystal clear that there's no single best protocol, only the best protocol for the specific task at hand. And that brings us to part 5, making the right choice. So how do we turn all this theory into a practical decision? Let's boil it all down into a really simple guide. It really just comes down to these 3 questions. First, is this for external developers? If the answer is yes, just default to REST. It's easy to use and everybody knows it. Second, is this for internal services where speed is absolutely critical? If yes, gRPC is your best bet to slash that latency. And third, do my services need to be decoupled and resilient? If the answer is a big yes, then you should be looking at an asynchronous approach with something like Kafka or RabbitMQ. So the key takeaway here is this. Your choice of communication protocol is so much more than just a technical detail. It fundamentally defines the relationships between your services. It's the difference between building a rigid system where everything is tightly linked and creating a flexible, resilient ecosystem where services can evolve and operate on their own. Your services can all talk. The real question is, are you setting them up to truly listen? Thanks for joining this Explain.